Good morning, Matrix. So we're continuing today with finance, and for the rest of the finance section, we're going to be working through the notes that I put on your WhatsApp group. And there are quite a few examples that we're going to work through in this lesson, and I will be sending you some worksheets that pretty much cover everything you need to know for Matric AP Finance. So from here on out, you can use the red books as a supplement. All right, so we're on page 1. This is John's college notes. These were actually a workshop that was done a few years ago for AP Maths teachers by St. John's. All right, so example 1. A sum of money is invested for 12 years. 3 years at 12% per annum, 5 years at 13.25% per annum compounded monthly, and 4 years at R% per annum compounded quarterly. After 12 years, there is 5 times as much in the account. Question 1, calculate R. And question 2, what is the effective annual rate over the 12 years? Okay, so if we let the amount of money that was invested equal P, then it says that after 12 years, there's 5 times as much. So in other words, our future value is going to be 5P. All right, and a certain principal was invested. Okay, so firstly, it was invested first for 3 years at 12% per annum. All right, they haven't given a compounding period, so we assume then that it's effective. So that means 1 plus 0.12 to the power of 3 for the 3 years that it's in. It's then invested for 4 years at R% per annum for 5 years at 13.25% per annum compounded monthly. Okay, so then we're multiplying that amount by the 0.1325 over 12 because it's monthly, and because it's 5 years, 5 times 12 is 60 periods in those 5 years. And then lastly, we are multiplying by a rate that is compounded quarterly, so R% over 4. And that is to the power of 16 because it's quarterly for 4 years. So it'll be to the power of 16. All right. So we can now easily solve for R. And the way that we do that, you can do it straight on your calculator. You don't have to show any work, but I'm just going to show you how we do that. Remember, we want to isolate this bracket. Okay, so because of the 16, we're going to take the 16th root. The p's cancel. All right, they both divide through. So we're going to take the 16th root on the left-hand side of 5, and then into that 5, we're going to divide this whole expression. Okay, so we're going to have 1 plus 0.12 to the power of 3 times 1 plus 0.1325 divided by 12 to the power of 60. And that'll equal 1 plus r to the 4, because we've already taken the 16th root of both sides. Okay, so you're going to punch that thing into your calculator on the left-hand side, and we then subtract the 1 from your answer, and then multiply your answer by 4 to get r as 0.1555, etc. And then obviously, because that is given as a decimal, you're going to multiply your answer by 100 to get to 2 decimal places, 15.56%. Okay, so this is question 1. Right, for question 2, they ask now what is the effective annual rate over the 12 years. Right, so the effective annual rate means that over the 12-year period, we now want to see what the rate is if it was compounded annually that would yield the same result. All right, so that means we're still going to end up with 5 times our investment, but this time our rate is going to be an effective rate, so it'll be to the power of 12 because it's over 12 years. All right, so again, now the p's will cancel, and so you're going to take the 12th root of 5 on your calculator. That'll give us 1 plus r, and then lastly, you're going to subtract the 1 to the right-hand side, and that gives you 0.1435, and then you multiply that answer by 100 again because we want it in percent form. All right, you always give it in percent form, and that gives you 14.35% rounded off to 2 decimal places. All right, example 2. Now, this example brings in something that we don't deal with in core with regards to depreciation. And that is the fact that as a truck depreciates, it also actually is subject to inflation. In other words, it doesn't just lose value, but the way that in the inflation rate works is that that truck can still gain a little bit of value because of inflation. All right, so the two kind of work off each other. All right, to put it in a different way, imagine that there was no inflation. So that truck would lose value. So say now it's now 1.2 million, as it is in the example, and there's no such thing as inflation. All right, then in 4 years' time, that truck might be worth, let's say, 500,000 Rand because it's lost value, it's gotten older, and so on. But because of inflation, it tends to be worth a little bit more because the buying power of money has decreased over time. So instead of 500,000, the inflation rate might push it up to maybe 600,000. Okay, so that's what we're going to be looking at here. So example 2 says, a truck value is now at 1.2 million. It depreciates at a rate of 16% per annum, but is also subject to inflation at 6% per annum. What is the value of the truck in 4 years' time? That's part 1. And then part 2, what is the net rate of depreciation? In other words, the one rate, the depreciation brings the value down, but the inflation brings the value up. So what is the net difference between the two? In other words, kind of like the middle ground. Okay, so the way that we do this when something is depreciating and it's also being offset by appreciation, we would say that the final amount is equal to the principal. Okay, 1.2 million. Well, I've got one too many zeros there. 1.2 million. We start with well, it doesn't matter what you start with, but I'm going to start with the depreciation. All right, so that was 16%, and it was over 4 years, and they also didn't specify how it depreciates, but when they don't specify, you always assume reducing balance. Okay, whereas in core, they must tell you. If they don't tell you in AP, you're going to assume that it's reducing balance depreciation. All right, and then the inflation is at 6%, so that's now compound interest. It's compounded, because it's inflation, it's always going to be compounded annually, and that's over 4 years as well. All right, so that on your calculator gives you a value of 754,261 Rand and 35 cents. Okay, so that was part 1, where they asked what the value of the truck would be in 4 years' time. All right, then part 2, what is the net rate of depreciation? So now you're only going to use a depreciation formula. Okay, so we're going to start with our value of the truck in 4 years' time, which is 754,261 Rand and 35 cents. And we know that the present value, the principal amount, was 1,200,000. And we're using the reducing balance formula. So you can easily put this onto your calculator now. So you're going to take the fourth root of 754,000 over 1.2 million. And then you're going to take the 1 over and subtract it. Then you have to divide by negative because the R is negative. Okay, and you're going to get your R value, which you then multiply by 100 to get 10.96%. Okay, I'd encourage you to test that on your calculator, please, to see that you do get the correct answer. Also, just have a look at the difference with the net rate compared to the original rates. Okay, so it's definitely not going to just be halfway between the depreciation and the inflation because they're different to each other. All right, they're not like, it's not like 16% depreciation, 16% inflation. If that was the case, then the car would still be worth 1.2 million after 4 years. Okay, but the depreciation rate was 16%. So it should have depreciated by 16% over the 4 year period, but because it inflated in value because of the buying power of money by 6% in annum, then it kind of averaged out to 10.96%. Okay, example 3 is really to just give you some kind of an idea of how we can sketch the repayments of loans when there's different circumstances happening throughout the period of the loan in a graph format so that you can understand what's happening. Okay, so let's read it, example 3. All right, so it says, consider the following scenario. A man takes out a loan to be repaid over 10 years. He pays nothing back for 2 years, but then he starts paying back with regular monthly payments. After 6 years, he makes a large cash injection, which is less than the outstanding balance, and then adjusts his monthly payment so that the loan is still fully amortized, which basically means paid off, after 10 years. Make a sketch of the graph of outstanding balance against time. Right, so we're going to start with our axes. And on the y-axis, we have the outstanding balance. And remember, we don't have any values here. The only values we have are the time periods, okay? He does something, it's over 10 years, he pays nothing for 2 years, in 6 years he does something, and so on, okay? So we don't have any financial values, so we can't put any actual values on the y-axis. But we do know that it goes up to 10 years. We know that something happens after 2 years, and something else happens after 6 years. Okay, so before we actually do the graph itself of his situation, you need to understand what the outstanding balance would look like if he had paid regular monthly payments. And effectively, it's an exponential graph. It's a decreasing exponential graph that looks like this. Right, so the way that a loan works is in the first few years, the outstanding balance decreases very gradually, okay, because that's when you're earning your most interest on what you owe. So although you're making payments, you are having to pay a lot off in interest because the outstanding balance is so high. Okay, so that's what it should look like. It goes gradually down as you make payments, and the further you get into your loan, the gradient of that graph decreases more rapidly until you end up with 0 after the 10-year period. Okay, so let's have a look. The question asked, make a sketch of the graph of outstanding balance against time according to his situation. All right, so what I'm going to do is just to put some vertical lines where our key time points are. Right, and then that just helps us to be able to work out exactly where everything should go. Okay, so I'm going to do his outstanding balance in red. So it says that for the first 2 years, he pays nothing back. So that means that the outstanding balance will increase for those 2 years. So he's going to end up owing a lot more. Okay, but then it says after 2 years, he starts paying back with regular monthly payments. All right, so those regular monthly payments are going to start to bring the graph down. And the graph will get closer and closer and closer to the green line, okay, which is what he actually has to pay. Now what's interesting is if he'd carried on like that, I'm going to just redo that line quickly. Okay, if he had carried on like that, so in other words, yeah, it would look something more like this. Okay, if he'd carried on just making those regular payments, then actually his payments would always, his outstanding balance would still be higher than what he owes. Okay, but it says then that after 6 years, he puts a cash injection, which is less than the outstanding balance. In other words, he doesn't pay it off completely. So that cash injection after 6 years brings the outstanding balance down a certain amount, not to 0 because it says it's less than the outstanding balance, but something like this. Okay, so it doesn't really matter where this endpoint is. It could be anywhere between the green line and the x-axis, but not including. Okay, but because it's a large cash injection, we assume it brings down the outstanding balance quite a bit. Remember, we don't have values to work with, so this is all hypothetical. And then lastly, it says that he adjusts his monthly payment so that the loan is still fully amortized after 10 years, which means that from this point, his regular payments then eventually bring the loan to zero. Okay, on the next page is just really for your interest, where it explains it. Well, it shows graphically and I know the quality of the diagram is really not great. You can't read anything there, but I'll help you through it. Effectively, on the y-axis are the amounts, and on the x-axis is time. All right, so we've got two lines there. We've got the one that starts high up on the y-axis and decreases, and one that starts low on the y-axis and increases. Okay, so the graph looks something like this. Now, the graph that's decreasing represents the interest that is paid. Okay, and that obviously starts quite high up because at the beginning of the loan period, you owe the most amount of money. So obviously the interest on that amount of money is going to be higher. The more you pay installments, the less that interest gets, okay? Until when you've paid off the loan, and just before then, you're paying very little interest because there's very little outstanding, and it eventually gets to the x-axis and you're paying no interest because you've paid the loan off. Then the other graph is the reduction in the outstanding balance. Now, it's weird because it looks like it's increasing and it is increasing, okay? But you must understand that it doesn't represent the outstanding balance. It represents how much the outstanding balance has reduced by. Okay, so in other words, right at the beginning, it's reduced by a very little bit because you've made one payment. Okay, but the more you make payments, the more that loan reduces until we get up to the top and the outstanding balance has reduced by the total amount. Okay, if you don't get your head around this graph right now, don't stress. There's going to be more on this in lessons to come. And then if you look just below that graph, that is a graph with just the outstanding balance, which makes perfect sense. Okay, it's a great outstanding balance to start with, and that just decreases. So that's similar to the green line that I did on the previous graph for that example that we did together. Okay, over the page, we have now missed or additional payments in future annuities. So in core, you've kind of only really done it when there's that additional payment right at the beginning. But now we're going to look at when there's a little bit more that changes throughout the timeline. Okay, and the little tip that they give there, the simplest way to approach these problems is to calculate the annuity as if there is no missed or extra payment, and then you delete or add, if it's an extra payment, the individual payments with the relevant amounts of interest. All right, example 5, and yes, there's no example 4. We're moving straight on to example 5. Okay, so Susan invests 5,000 Rand at the end of each month into an account giving compound interest with an effective return of 11% per annum. After 4 years, in other words, 48 payments, the interest rate changes to 14% per annum compounded monthly, and she increases her payment to 7,000 Rand per month. Furthermore, she misses the 24th and 25th payments, but her 70th payment is increased to 17,000 Rand. Calculate the amount in the account after 10 years. Okay, so I suggest you have the question in front of you while I work through the solution with you. So what's really useful in a question like this is if you use a timeline. All right, and on this timeline, we're going to reflect two different things. Firstly, we're going to reflect the amounts of money that are invested and the amount of money that is invested, and secondly, the interest rates and how they change. Okay, so firstly, we are dealing with monthly payments. So we're going from T0 to T120, okay, because it's 10 years, so 10 times the 12 gives us 120. Her first payment of 5,000 is made at T1, and those continue. Then at T24, she misses a payment, and at T25, she also misses a payment. The 5,000 Rand payments then continue until T48. It's also 5,000 Rand. And it says then that she increases her payment, so at T49, to 7,000 Rand. Those payments continue. But at T70, she puts in an extra 10,000 Rand. That's over and above her 7,000 Rand. Okay, so that month effectively she's put in 17,000 Rand. Okay, so I know in the question they said 17,000 Rand, but for making the working out easier, we assume that she still does her 7,000 and the additional is only 10,000. And because it's future value annuities, we also assume that her last payment is made right at the end of the period. All right, let's look now at the interest rates. So it tells us that for the first 48 months, the interest rate is 11%, compounded annually. And then for the remainder of the period, basically once she increased her payments to 7,000 Rand, the interest rate becomes 14%, and that's compounded monthly. All right, so because payments are monthly and we have a effective rate for the first 48 months, we need to convert that effective rate to a positive rate. Okay, so you might remember the formula that you used to do that. Okay, so I always start with the unknown. We now want to work out a monthly rate. Okay, so it'll be over 12 to the power of 12. But we've been given an effective rate of 0.11. So that's effectively over 1 to the power of 1. Okay, and so now to work this out, you're going to first take the 12th root of both sides. So you don't need to show any of this working out. But for the example, I'm going to show you. So we're going to take the 12th root of both sides and subtract that 1 on the right-hand side once we've done that. Right, so we're going to get r over 12 on the left-hand side. And then we're going to get the 12th root of 1 plus 0.11. To that we subtract 1. And then lastly, multiply the whole thing on the right-hand side by 12. And then this gives us a rate of 0.1048. Okay, to 4 decimal places because, remember, once we put it as a percentage, the decimal place moves. Okay, so rather leave your rate to at least 4 decimal places. Okay, so that effectively means that this rate then becomes 0.1048 as a monthly rate. If you need to take any of this down, just pause because I'm going to erase the working out at the bottom. Okay, so this is quite a long sum, so try to keep up. Well, you don't really have to keep up, you can pause if you're not keeping up. Okay, so it's clearly a future value problem. And we're going to start with the 5,000s. Now, the moment there's a change in money that is the regular payment, we treat them almost as if they are 2 different accounts within the same account. So we're going to look at the 5,000 Rands first. Okay, so she invests 5,000 Rand a month, and that's at the interest rate we've just worked out, 1048 over 12. And that's also in the top, 1048 over 12. And she does that for 48 months. And after the 48 months, obviously all those 5,000 Rands have accumulated. And by the way, there was a gap between the first payment. Okay, they did not specify that there was an immediate payment. Okay, just said at the end of each month. So that's why we didn't have to increase the exponent by 1 for that initial payment that sometimes happens. Okay, so now at this point at the 48th term, what we do is we now grow that money that's in the account for the remainder of the period. Okay, so it's going to be 1 plus 0.14 over 12 to the power of 72, okay, because 120 minus 48 is 72. So for the remaining 72 months, that amount accumulates, okay. Once I've finished, in fact, no, let me do it now. I'm going to give you an idea of exactly what we're doing, okay. So here's her account. I'm going to just do it like this, and it goes to T120. Okay, so in green, these are her 5,000s. Okay, so the 5,000s go until T48. Then what happens is she then starts with her 7,000s. So the 7,000s I'm doing in red, and the 7,000s go all the way to the end of the period. Okay. And we're gonna deal with that 24th and 25th payment shortly. Okay, so what we're doing now is we're going to grow this amount to the end of the period, and then when we add the whole green amount as well as the red amounts, which represent the 7,000s and all the interest it would have accrued, then we get the total amount. Okay, but we obviously now have to deal with those missed payments. Okay, so I'm going to erase this quickly. All right, so back to the problem. We have grown the 5,000 Rand now right to the end of the period. Okay, so now we're going to come back and look at the 7,000 Rands. So the 7,000 Rands is also going to be a future value. By the way, I did this whole problem and I got to the end of it and tried to save it and realized it all had disappeared. So I'm redoing it from the beginning. And you'll see how disappointed I am when we get to the end of this problem when you see how long it is. I don't know where it went. So I'm back to here. Okay, so 7,000 Rand, not that you care, is into 1 plus 0.14 over 12, and that's to the power of 72 now, minus 1. Okay, I know we haven't dealt with the missed 5,000 Rand payments yet. We're going to get to that. Okay, so in other words, what I like to do first is just work out, as it said in that tip earlier, is work it out first as if there are no missed payments. Or extra payments. The only two regular payments here are the 5,000s until term 48 and the 7,000s until the end of the term. All right. The two missed payments of 5,000 we deal with later, and the extra payments, the big payment of 17,000 Rand, we deal with later. Okay. And remember that 17,000 Rand includes the regular payments of 7,000 Rand, so it's really just an extra 10,000 Rand over and above the 7,000 Rand that was deposited as a regular payment. All right. So we are now going to deal with the missed payments. Okay, so obviously if I could, I would carry on here, but I can't. So I'm going to go to the beginning of the next line, but it's still part of the same equation. Okay, so we're now going to take away that 5,000 Rand, the first 5,000 Rand that she missed. Okay, but now you need to understand, and I'm going to use red here, she missed the payment here. So that 5,000 Rand that she missed would have earned interest all the way up to T48 at this interest rate, and then all the way to the end of the period at that interest rate. Okay, so we've got to break it up to deal with that change in interest rate. All right, so we first have to work out how many payments are there from this point to 48. Okay, it's quite simple. We're going to say 48 minus 24. So we get 24. So in other words, there's another 24 months from this point, where, including this point where she missed, all the way up until the end of the 48th term, where it could have earned interest, but it didn't. That's why we're subtracting. Okay, so it's at the interest rate of 0.1048 over 12 to the power of 24. Okay, 48 minus 24 is 24. But then we're now at this point. It still loses out interest that it would have earned from this point until the end of the term at 14% compounded monthly. Okay, so in other words, for another 72 months. Same 72 that we used there. Okay, so that gives us 1 plus 0.14 over 12 to the power of 72. Okay, if you can't quite wrap your head around that, wait till the 25th payment that she missed and see if that maybe helps you understand. Okay, so now we're going to take away the 25th payment. Okay, it might just be helpful for you to label this. So this one is the missed 24th payment. And so we said 48 minus 24 equals 24. And this 24 is that 24. Okay. And now we're taking away the 25th payment. So this one is going to be the missed 25th payment. So for the exponent for this one, we're going to say 48 minus 25. And that equals 23. So that will be our exponent of how many payments between the missed one and the 48th month it has lost interest. All right, so it's 1 plus still 0,1048 for this period over 12, and this time to the power of 23. Okay, and then that is, I'm just circling it so that you see where it comes from. And then we still have to grow that for the last remainder of the period to get our interest that it would have earned right until the end of the period. Okay. And then lastly, we've got to deal with the 10,000 Rand. So that was a deposit. So now we've got to work out how much extra interest that 10,000 Rand has earned. Okay, remember that this first line deals with if there were just regular payments of 5,000 Rand for 48 months and then regular payments of 7,000 Rand for the next 72 months. Okay, we're now dealing with the missed payments and the deposit. All right, so because it's a deposit, we're adding 10,000 Rand. Now this 10,000 Rand, if you go back and look at the timeline, is at this point. Okay, so it's dealing with that interest rate. All right, so we don't have to worry about the 0,1048. We're straight into the 14% compounded monthly. Okay, so that is 1 plus 0,14 over 12. And then for the exponent, look back at the timeline. This 120 is the total amount, but this payment was made at term 70. So it's as simple as saying 120 minus 70 means that there's another 50 months between when she deposited the 10,000 until when the account matures. Okay, so there's 50 months during which that 10,000 Rand can earn interest. Okay, you are then done with the sum. You now have to put it on your calculator. Okay, so I'd encourage you, please, to put this on your calculator so that you can see you get the correct answer. And I also don't put the whole thing on your calculator as you see it. Your calculator won't handle it. Okay, so you actually need to break it up. So you're going to first put in this onto your calculator, and then at this point you press equals. Then you put this on your calculator, and then at the end of that you press equals. Basically before every plus and minus sign you're going to press equals. So you're going to press equals again after that. You're going to press equals again after that, and then obviously right at the end to get your final answer. Okay, that's all for today. I think your brain might be a little bit fried, and we'll do some worksheets on this in the next lesson. Okay, but for now, if you still have time, I recommend that you go through these examples again, particularly this last one, just so that you can understand and make sure that you know what's going on before our next lesson. Thanks, guys. Have a great day.